So this is Chapter 6, Section 4, Rational Exponents. Our learning objective is to simplify expressions with rational exponents. And usually when we talk about rational, it puts into the possibility a numerator and a denominator. So we're going to be looking for fractions in the exponent. Our essential understanding is you can write a radical expression using a fractional exponent instead of a radical sign. So in general, and this is what I want you to write down for sure from this essential understanding, the nth root of x is equal to 1 over n. It's x to the 1 over n. So your power is 1 over whatever that root is. So if it's cubed root, it would be x to the 1 over 3. The exponential form indicates the principal root. So 36, square root of 36 is 36 to the 1/2 power. Cubed root of 64 is 64 to the 1/3 power. Fourth root of 16 is 16 to the 1/4 power. So what we're going to do is we're going to bring in the properties of exponents and apply them to fractions. So we're going to take that principle of the root being a fraction and apply exponent rules to that. Okay, so we are going to simplify each of these expressions. So 64 to the 1/2 power, that's the same as the square root of 64. Hello, Ocho. 11 to the 1/2 power times 11 to the 1/2 power. When we multiply the same bases, we add the exponent. So that's 11 to the 1/2 plus 1/2. 1/2 and 1/2 is 1, so that is just equal to 11. 3 to the 1/2 power times 12 to the 1/2 power. This is the same as the square root. Let's see. My square root turned out giant. The square root of 3 times the square root of 12. We learned in previous sections that when we have two square roots, same index, we can write this as a product of each of these numbers underneath the square root. So this is 3 times 12. What is 3 times 12? 36. And can we find the square root of 36? Yeah, it's just 6. Okay, so the skill here is being able to apply your square root and your root knowledge to problems with fraction exponents. All right, so talking about rational exponents, we know, let me make this a little bit bigger so you can see it better. We know that when I have a base, 1 over n in the exponent is the same as that base to the nth root. When I have a number other than 1 in the numerator of my exponent, that becomes my power. So a to the m over n is equal to a raised to the m power, nth root of that value. You can write it either way. You can apply the power first and then take the root, or you can do the root first and then apply the power. Your method should be whatever gives you, makes your answer easier to find. If m is negative, a cannot be equal to 0. Got it. Okay. And then just a reminder, negative exponent implies 1 over the base with the it implies 1 over, so it reduces that. All right, so if you look at our example problems, what are the expressions w to the negative 5/8 and w to the 0.2 in radical form? Ooh, that's fun. Let's answer A down here. So w to the negative 5/8. Negative on this one. Just a double thing works. Okay, w to the negative 5/8. So let's write the root index in, and we'll put the negative on the 5. I'm going to go ahead and apply the negative so I have just a positive exponent, because you typically never want to leave exponents negative. When you're simplifying, they'll want you to write it as a positive exponent. So this will be 8th root of 1 over w to the 5th, or 1 over w to the 5th, 8th root. Because what's the 8th root of 1? Or 1 to the 8th root? 1. Just 1. So then we can go ahead and make the numerator 1, and the 8th root is only applying to the denominator. Okay, so let's do w to the 0.2. 0.2, if we just do it, it's 2/10. So we can write that as 2/10. I can reduce that though. 2/10 reduces to 1/5. Let's say 5/5. To 1/5, and then so that is the 5 goes in the root and the w goes inside. All right, so let's look at B. What are the expressions 4th root of x cubed and 5th root y to the 4th power in exponential form? So 4th root of x cubed, our exponent goes in the numerator and our root goes in the denominator. 5th root of y to the 4th, same rules apply. It doesn't matter whether you're applying the root first and the exponent second. The power is still in the numerator and the root is still in the denominator. Y is equal to the 4/5. All right, so let's take a look at some properties. We have seen these properties before. So if you don't already have them memorized, definitely write them down. When you multiply same base, you can rewrite them as one base with the exponents added. When you raise a base with a power to another power, you multiply the powers. When you have multiplication inside parentheses raising to a power, you can rewrite that as each individual item raised to that power and then multiply. If you have a negative exponent, You can rewrite that as a positive exponent in the denominator. If I have same base being divided, you can write that as one base with the exponent subtracted. And if I have division inside parentheses being raised to a power, I can rewrite that as each item, the top raised to the power divided by the bottom raised to the power. Okay, so we're going to use these properties to simplify these questions. I'll start here. Okay, what is each product or quotient in simplest form? So I'm going to convert it to fraction exponents and then apply the exponent property. So square root of 3 is 3 to the 1/2 times fourth root of 3 is 3 to the 1/4. That means I can go 3 to the 1/2 plus 1/4, which, if I find a common denominator, 1/2 is 2/4 plus 1/4 is 3 to the 3/4. So I can rewrite that as fourth root of 3 cubed, or fourth root of 27. Simplest? All right, so for this next problem, I'm going to rewrite each of these items. Square root of x cubed is x to the 3 halves over cubed root of x squared, that's x to the 2/3. So then I use my division property of exponents. This is x to the 3 halves minus 2/3. If I find a common denominator, the first factor of both 2 and 3 is 6. So this is x. So 2 times 3 is 6, so 3 times 3 is 9. 2 times 3 is 6, so 3 times 2, 3 times 2 is 4. 2 times 2 is 4. 9/6 minus 4/6 is 5/6. And we can rewrite that as a radical. And that's our simplified form. Okay, last one. Square root of 7 is the same as 7 to the 1/2 times cubed root of 7, that's 7 to the 1/3. We can rewrite that as my exponents being added. 1/2 plus 1/3. So if I have a common denominator of 6, 1/2 is 3/6 and 1/3 is 2/6. 3/6 plus 2/6 is 5/6. So we get 7 to the 5/6, or 6th root of 7 to the 5th power. All right, so now we're going to get to a place where order is going to start to matter. So the question is, what is each number in simplest form? 32 to the negative 3/5. So this is equal to 1 over 32 to the positive 3/5. That takes care of the negative part of that exponent. So 32, is it easier to raise 32 to the third power, 32 times 32 times 32, or is it easier to take the 5th root of 32? Is 32 a perfect 5th root? So remember the chart that we made last week. So 32 is a perfect 5th root. So we're going to want to take the 5th root of 32 first. So this is 1 over 5th root of 32, and then we're going to cube it. That's how you make the decision on which to do first, the root or the power. Whatever's going to be easiest is the one you're going to do first. So this is 1 over, the 5th root of 32 is 2, and then 2 to the third power is 2 times 2 is 4, times 2 is 8. So the answer is 1 over 8. All right. So using that same chart, 16 to the 3/4. Is it, because right now I can tell you, I cannot take 16 and multiply it by itself 3 times in my head. I have to write that down or I have to use a calculator. So is it easier to do that, 16 to the 3rd, or take the 4th root of 16? Is 16 a perfect 4th root? Yes. The 4th root of 16, because you go 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So the 4th root of 16 is 2, and then I cube it, and 2 cubed is 8. All right, 9 to the negative 3/2. Oh my goodness. So let's fuss with this a little bit. First, let's make it not negative. Next, let's write 3/2 as a, or 3.5 as a fraction. 3.5 is 7 over 2. So is it easier to take 9 to the 7th power or the square root of 9? Which one's easier? Square root of 9 or 9 to the 7th power? Which one can you do in your head? I can do the square root of 9 in my head, so that is 1 over 3 to the 7th power. And I'm going to have to go mad calculator skills to find quickly for you 3 to the 7th. 2187. Okay, so now let's make this as hard as possible. I have 8x to the 15th raised to the negative 1/3. I'm going to take care of the negative first and go 1 over 8x to the 15 raised to the 1/3. I'm going to go 1 over 1/3 power is cubed root. So I'm going to go 8 to the 1/3 times x 15 to the 1/3. The 1/3 power distributes into this multiplication here. This is 1 over, I know the cubed root of 8. It is 2. And x to the 15 times 1/3 is equal to x to the 15 thirds. I can do that math. 15 divided by 3 is 5. So my answer is 1 over 2x to the 5th. Simplest form does not have negative exponents. So make sure your answer doesn't have negative exponents. All right, last one. So I'm going to give everything inside here a 3/2 power. So first let me rewrite 4th root. So this is 9x y to the 1/4 raised to the 3/2. I'm going to give each of these items the 3/2 power. 9 to the 3/2, x to the 3/2, and y to the 1/4 3/2. So I'm distributing out using that property of exponents, giving everybody that power. I'm going to rewrite this as square root of 9 to the 3rd power. I'm going to rewrite x as cubed root x squared. And I'm going to do this multiplication here. Y to the 1/4 times 3/2, that's 3/8. One more level. Square root of 9 is 3. 3 to the 3rd power is 27. I'm kind of stuck with this cubed root of x squared. And then I'm going to have 8th root of y cubed. And there is nothing we can do to make that any simpler. Go ahead and take a moment, write a summary, make a comment about the properties of x. There's tons of properties of exponents, so that's minimum 8 sentences right there. You can summarize them in a couple of sentences. Please make note of what simplest form is. Don't forget to mention the negative exponent and what it does. That's one of the properties that gets lost from year to year. Algebra 1 to Algebra 2, we forget that a negative exponent means 1 over. And that's it for today.